Hello everyone, today we're going to be looking at an application of integration, which is finding areas. So back in Calc 1, you learned that the integral from a to b of f of x dx gives the area under the curve f of x, assuming it's positive, from a to b. What we're going to do here is we're going to find the area between two curves. So here are a couple examples graphically. And if one function is on top of the other, then the area between the curves is just the integral from a to b of the top function minus the bottom function dx. So we're going to see this in a couple examples. So the first one is that first picture I just showed, which is the area between the curves y equals x and y equals x squared. Sometimes we're given a and b, sometimes we need to find them ourselves. We're not always given the picture either. So to find the bounds, we just set our two equations equal to each other. So when does x equal x squared? So it's going to be a little bit of algebra in here as well. So don't forget that in order to solve a quadratic, you want to put one side equal to 0 and then either use the quadratic formula or factor. This one's a fairly easy one to solve, and it's also, we have the picture here so we know the answers. And x is 0 and 1. So again, we have to consider, is one function always on top of the other? And if we look at it, we can see that yes, the line is always on top of the parabola. So that means our equation is going to be the line y equals x minus the parabola y equals x squared. So we have the integral from 0 to 1 of x minus x squared dx. We integrate, and then we find the definite integral. Don't forget that these are area problems. Area cannot be negative. If you end up with a negative answer, that means you probably flipped them and you probably did bottom minus top. So make sure that your answer makes sense. Area cannot be negative. And if you have a picture and you see there is in fact an area, it can also never be 0. So here's another one. And again, this is the picture that I showed on the first slide. So let's find the area between y equals x cubed minus x and the x-axis. Again, the first thing we have to do is find the bounds. So I'm going to set my two equations equal to each other. Notice the x-axis is the equation y equals 0. So I want when is x cubed minus x equal to 0. And again, you can factor this. It's again fairly easy. And you should get -1, 0, and 1. Which hopefully makes sense. If you look at it, there are, in fact, 3 zeros. And again, if you're given the graph, it's fairly easy to see that it's -1, 0, and 1. Now we have to notice that from -1 to 0, the curve is on top, and the x-axis is on the bottom. But from 0 to 1, it's flipped. The x-axis is on top, and the curve is on the bottom. So because of this, because it's not the same function on top, we need to split up our integral. So we're going to have the integral from -1 to 0 of the curve minus 0, and then we're going to add to it the integral from 0 to 1 of 0 minus the curve. Okay, so again, you always have to make sure that you're doing top minus bottom. So if the top function changes, you have to split up your integral. I'm not going to spend time here going over the integration itself because that we did in previous sections. This is actually a Calc 1 problem at this point, so I'm not going to spend time going over that. So what I suggest you do is pause the video, do out the actual math, and make sure you're getting the same answer that I'm going to give you. Okay. So if you do this out, you should be getting 1/2. If, however, you didn't realize that the two functions changed positions and you just integrated from -1 to 1 of our function, so in this case x cubed minus x, you would have gotten 0. And you know that cannot possibly be correct because I have a yellow area there, and that area is not 0. So you always got to be really, really careful again when you end up with a negative or with a 0 because something happened. Sometimes the curves are not on top of each other, but rather they are next to each other. So here's an example. We're going to look at the area between y equals the square root of 1 minus x and y equals the square root of x minus 4. if you notice, our functions are not on top of each other, but rather they are next to each other. So this is going to change our integration. We can't do the integral of top minus bottom dx anymore. There is no top, there is no bottom. Instead, we integrate over y, and it's the integral from, say, c to d of the right function minus the left function dy. Okay? So in this picture, we have our right function right here, which is this guy, and our left function, which is this one. If you don't know which one's which, just try plugging in a value. Right? If I plugged in x is 1, here I'm going to get undefined. Here I'm going to get 0. So 1, 0 must be on my first function. Okay, you can always plug in points if you're not sure which function is which. So we have a left function, we have a right function. And so, again, the main thing to take away here is that it's over dy. So I cannot use y equals square root of 1 minus x. I can't use y equals f of x. I need to change it to x equals g of y. So that's going to be part of the problem. I need to change everything that's in terms of x to be in terms of y. And remember, the c and d, again, are y values. So I don't care about the x values, I care about the y values, which in this case is 0 to 1. Okay. I didn't mention here, but in the problem, I would have also had to have given you the y equals 1 part, otherwise you wouldn't be able to solve it. The area would be infinite. So that's part of the problem. So our c and d are going to be 0 to 1, and then I need to rewrite my functions instead of y equals something into x equals something. So that's what we're going to do next. So we start with y equals the square root of 1 minus x, and we need to solve for x. So the first thing we do is we square both sides, and then I want to get x by itself. So I'll add the x and then subtract the y squared, or I'll subtract the 1 and then divide by negative 1. But either way, I should be getting x equals 1 minus y squared. And then I do the same thing for y equals the square root of x minus 4. I'm going to square both sides, and then I'll add the 4 over. So I get x equals y squared plus 4. So these are my left and right functions that I'm going to be subtracting. So again, it's the integral from 0 to 1, my y values. And then this one was my right function, so it goes first. And then my left function goes second. And remember, it's always the bigger one minus the smaller one. So in a number line, the bigger numbers are to the right, which is why you're doing the right minus the left, the bigger minus the smaller. Make sure you always clean it up before you start integrating. I don't want to integrate 4 terms when I only have to do 2. Okay, so always simplify before you start doing anything else. But again, I'm not going to go through the integration itself, it's just Calc 1 stuff. So you should be getting 11 over 3. Sometimes you can actually do either method. So find the area between y equals x squared and the y-axis from y equals 0 to y equals 4. So the fact that they're giving you the y values here is probably a good hint that you might want to do it in terms of y, but this one you can actually do either way. So we'll do it both ways. If I'm doing it in terms of y, then I need to do the right function minus the left function. The right function is my curve, which is at this moment written as y equals a function of x. But again, I need to rewrite it. So if y equals x squared, then x equals plus or minus the square root of y. Don't forget the plus or minus. We're going to see in another example it's going to be really important. We need to figure out which one are we actually looking at. Is this the positive square root of y, or is this the negative square root of y? So if you notice, my x values are positive, right, as I go up. So I do want the positive square root. Occasionally, however, we will want the negative, so don't forget to keep that in mind. Okay, so our right function is x equals the square root of y. Our left function is the y-axis, which is x equals 0. Okay, so it's already in terms of x equals a function of y. So my right function, root y, my left function, 0. My bounds, again, are given to me 0 to 4. So if I'm doing it in terms of y, that's what it will look like. The integral from 0 to 4 of the square root of y minus 0 dy. However, I could also say that this is a top minus bottom function. My top function would be y equals 4, and my bottom function would be y equals the square root of x. So I could do top minus bottom and leave it in terms of x. If, however, I do it in x, that means I need to change my bounds to be x values. So I can either look on the graph and say that it goes from 0 to 2, or I can use my y values and plug them in to find my x values. So if y is 0, then x must be 0. And if y is 4, then x is either 2 or negative 2. But again, clearly I want the positive 2. So I could also do the integral from 0 to 2 of, again, the top minus bottom, 4 minus x squared dx. Either case, you're going to get the same answer. So again, I want you to pause it and actually do out both integrations and make sure you get the same answer. You should be getting 16 over 3. Okay, so again, sometimes you can do either method. Usually you can do either method, it's just that one tends to be a lot easier than the other. In this case, they're both fairly easy. So let's try a couple more. Let's do the area bounded by y equals 3 over x squared, y equals 0, x equals 2, and x equals 3. So on these, in class and on the test, I'll always have the picture for you. In the homework, though, the book doesn't give you the picture, so I would either try to draw it out, right? You know what some of these functions look like. If not, if you use a graphing calculator. If you don't have a graphing calculator, you can always try wolframalpha.com to graph them. But again, on the test and in class, I will give you the picture, so you'll have the graph when it counts. So here is our picture of it. And again, we have to decide, is this a left and right, or is it a top and bottom? Hopefully, we can clearly see this is a top and bottom. Our top function is the curve. Our bottom function is the x-axis. Okay, so it's going to be a top minus bottom, so everything's in terms of x's. And again, we're given x values, so that's a good hint that you want to do it in terms of x. So we're going to integrate from 2 to 3 of our top function minus our bottom function. Right, I don't need to write minus 0 though. So we're just integrating 2 to 3 of 3 over x squared. Don't forget you're going to have to change that to 3 times x to the negative 2 before you integrate. But again, for now I'm just going to give you the answer. I'm going to assume that you're doing it out on your own though. And you should be getting 1/2. Let's try another one. Bounded by y equals 4 times the square root of x equals 0, y equals 1, y equals 3. Okay, so again, we're given 2 different y values here. It's a big hint that you probably want to do it in terms of y. That means that we have to take our equation and solve it for x. So if y equals 4 times the square root of x, we need to divide by 4. And then we need to square both sides. So the function we're going to be using is x equals y squared over 16. Okay. That will be the right-hand side. And then the left-hand side is our other equation here. X equals 0. And again, that's already in terms of y. It's already x equals. So then we have our right curve, y squared over 16. We have our left curve, 0. And then we have our bounds, 1 to 3. So that gives us this guy. And again, if we do the integration out, we get 13 over 24. So I could also, as I said before, do it in terms of x's if I wanted. I could do top and bottom, but you have to be really careful here because the bottom function changes. So no matter where you are, the top function is y equals 3, but the bottom function changes. Oops. So over here, the bottom function is the line y equals 1. Over here, the bottom function is the curve 4 times the square root of x. So I could do this as two different functions. I could do 3 minus 1 dx plus the integral of 3 minus 4 square root of x dx. And then I'd have to figure out the bounds. I know this one is 0 to something, and this one is something to what looks like 0.6. So I'd have to do a little bit of work. I'd have to figure out what the x value is right there where it changes. Okay, so like I said, you typically can do either one in terms of y or in terms of x, but one it seems to be easier than the other. So in this case, terms of y is a lot easier. There's only one integral. Right? But don't forget, you can do it both cases. So let's try another one. The function the area bounded by y equals x squared plus 5x and y equals 3 minus x squared. Okay, so we have two parabolas. You can't really see it as a parabola right now, but they do continue on. So notice that this parabola is 3 minus x squared. The negative x squared means the parabola is opening downwards. The positive x squared means my parabola is opening upwards. So we can tell which one's which. Again, if you're not sure, just plug in a point. Plug in 0. One of them you'll get 0. One of them you'll get 3. Okay. First thing we need to do, though, is find the bounds. Again, graphically, I can at least guesstimate what they are. It looks like -3, maybe somewhere near a half over here, but you want to actually find them. So again, we're just going to take our two equations, set them equal to each other, and then solve. Again, this is a quadratic. You want to make sure you put everything on one side, make one side equal to 0, and then either factor it or use the quadratic formula. But you should be getting what I had mentioned, -3 and +1/2. Okay. Now we have to determine, is our functions top and bottom or left and right? And hopefully you can tell it'd be a lot easier to do top and bottom. So the top function is again this downward facing parabola, which is the 3 minus x squared, and the bottom function is the normal sided parabola, which is the x squared plus 5x, the opening upwards parabola. So we're going to do the integral from the bounds we just found, -3 to 1/2, of the difference of our two parabolas. Again, to make sure you simplify it first and then integrate. Okay? And if you integrate it correctly, you should get the very lovely fraction 343 over 24. Okay. Make sure that you keep the whole area. Remember, I don't like rounding, so just keep it as the whole fraction. Don't try to round any of it. Here we have bounded by y equals x squared, y equals 2 minus x, and y equals 1. So we have what kind of looks like a triangle here. Again, we need the bounds, so we're going to do that first. We're going to set our two equations equal to each other. 2 minus x equals x squared. Again, it's a really nice quadratic, and you should be getting 1 and -2. And now, again, the next step is to determine, is it a left and right situation, or is it a top and bottom situation? And again, this one you could do either way. One way is slightly easier. And if you notice, our line bounds our area to the right, and our parabola bounds it to the left. So it will be faster to do a right and left situation here, which again means that we need to change all of our x's into y's. So I'm going to start with y equals x squared, and I'm going to solve it for x. So again, just like before, x will be plus or minus the square root of y. Now if we look at the part that's actually bounding our area, this is the negative x values, which means x is the negative square root of y here. I don't want the positive. The positive one would be on this side, which is what I don't want. So again, it's really important that you remember when you square root something, you have two options, the positive or the negative. And in this case, we want the negative. Our other equation is y equals 2 minus x. Solve it for x, and we get x equals 2 minus y. Next, we have to change our bounds. So our bounds we have are the x values. We need the y values. So I'm just going to take my first x, say 1, plug it into either equation, and solve it for y. So if x equals 1, y is also 1. And then when x is negative 2, y is 4. So our bounds become 1 and 4, the y versions of the x values. I want the y's. And then I'm going to put it together. I'm going to take the integral from 1 to 4 of our line, which is on top, is the 2 minus y. And then again, negative root y is the parabola. That's our left and right. Sorry, I said top. 2 minus y is the right. Negative root y is the left. So right minus left. And if we do that out, we should get 19 over 6. Again, if I wanted to do top and bottom, I could. Just notice that my bottom function, again, changes. So my line is always the top function, but this area here has the bottom function, y equals 1. And over here, we have the function of the parabola. So I have two different bottom functions, so I'd have to be really careful about that. Okay, so it's really, really important that you look at the picture. Again, I will give it to you in terms of in class and on the test, but on the homework, you'll have to figure it out yourself. So either a graphing calculator or by hand or by something like wolframalpha.com, something that will graph a function for you. Okay, so play around with it. Let me know if you have any questions, and good luck.